So we've analyzed our crude extracts by GC mass spec. Another way that we could analyze them is by thin layer chromatography. The thin layer chromatography plates that we use here are silica gel. So you want to handle them by the edges as much as possible. Avoid getting a fingerprint on the front. So I'm going to need 3 of these, one for each of the materials. And these plates have a finely divided SiO2, silicon dioxide, or silica gel, which is basically just highly purified sand. That, of course, won't stick to the plastic backing, so that SiO2 is suspended in a matrix of gypsum, which is calcium sulfate. And then in addition, there is a UV indicator on there that fluoresces under UV light, which allows the plate to be bright white. And then wherever there would be a spot, if the spot happens to absorb the ultraviolet light, there'll be a dark spot where it's no longer fluorescing. So if I turn off the hood light, you can see that that plate is glowing quite bright white under UV light. That's the work of the fluorescent indicator. So we need to figure out what we're going to run these TLC plates in, so we know what solvent mixture to make up. So we'll have chambers, our TLC chambers, screw cap jars here. And we'll probably need a different solvent mixture for each compound. So I'm going to label these V for vanillin and Ca for cinnamic acid and T for tryptamine. It's been reported in the literature that vanillin has been run on column chromatography in a mixture of 2 to 8 ethyl acetate and hexane or petroleum ether, or a 1 to 5 mixture of ethyl acetate petroleum ether. Generally, for thin layer chromatography, you want a mixture that is less, that is a little bit more polar. The RF values, or the retention, or how fast the compound moves, is dependent on how much water there is. And chromatography silica, which is in a jar like this, is generally a little bit more wet than the thin layer plates, which means everything moves a little faster. So we want to increase the polarity when we're running on a TLC plate. So if a 5-to-1 mixture of ethyl acetate to petroleum ether is good for a column, probably about a 3-to-1 mixture of ethyl acetate and petroleum ether will be good for thin layer chromatography. So we'll try a 3-to-1 mixture. So we'll put a milliliter of ethyl acetate in. And we'll add to that 3 milliliters of petroleum ether. Make it up to the 4 milliliter mark. So we have a 3-to-1 mixture of petroleum ether to ethyl acetate. That pipette is for the petroleum ether. So for vanillin, I'm going to give that a shot. 3-to-1 mixture, we'll just add all of that. 3 to 4 milliliters is a good volume in your TLC chamber. It's been reported in the literature that a 10-to-1 mixture of petroleum ether to ethyl acetate works well for cinnamic acid. So if a 10-to-1 mixture works well for petroleum ether and cinnamic acid, for chromatography, column, I think maybe a 7-to-1 mixture would be good for TLC. So we're going to add a milliliter of ethyl acetate. And to that we'll add 7 milliliters of petroleum ether. Make that up to the 8 milliliter mark. And we'll need about half of this for our chamber. And it's a little bit guesswork when you're first designing a TLC system. I want to make sure that's well mixed, so it's a uniform mixture. So I'm going to pour that into a 50 milliliter beaker and swirl that around. Make sure it's thoroughly mixed. And then I want about 4 milliliters, so I'll simply pour that in there until the volume in that chamber is a similar volume. And I can set that aside. Maybe I'll need it, maybe not. With a watch glass on top so that it minimizes the evaporation. So I've got a solvent system for vanillin, which is 3-to-1 hexane ethyl acetate, and a solvent system for cinnamic acid, which is 7-to-1 petroleum ether ethyl acetate. For tryptamine, because it's an amine and has hydrogen bond donors in addition to hydrogen bond acceptors, that tends to stick pretty tightly to silica. So an ethyl acetate petroleum ether mixture would probably need to be quite polar. So for the tryptamine, I'm going to try a 1-to-1 mixture and see if that's good enough. So we'll put 2 milliliters of ethyl acetate in. And then we'll add 2 milliliters of petroleum ether. Make that up to the 4 milliliter mark, which will be a good amount for our chamber. The other thing when one is running TLC on amines is it's frequently desirable, in order to keep the amine from getting protonated by the relatively acidic silica gel, it's frequently desirable to add a little bit of triethylamine so that if it does try to get deprotonated, it will immediately react with the triethylamine. So I'm going to add some triethylamine to that chamber. I think there may be some triethylamine already in the flame cabinet. If not, I will have to go and find some. Looks like there isn't any here. And one other place I can look in the lab. So the triethylamine is a stronger base than the tryptamine in all likelihood. So it looks like I'm going to have to go fishing. I'll turn off the camera while